We are going to look at the function, the quantity x minus 3 divided by 5, and find its inverse, and then verify whether what we find we will label as g of x is the inverse of the original function f of x. We begin looking for the inverse with our step 1, which is to replace the function notation f of x with the letter y. So y equals the quantity x minus 3 divided by 5. Often it is the case that a typed function can be rewritten and more easily understood if we use the horizontal bar for division as also the grouping symbol. Step 2 then involves interchanging the x and the y. So where you saw the y, you will now write an x, and where you saw the x, you will now write a y. Our final step then is, by using algebraic technique, solve for y. So we will multiply 5 times x, and that will equal y minus 3. Adding 3 to each side, we find that y equals 5x plus 3. We will further note that this then is our inverse function, and we will denote it for further discussion as our g of x function. Verifying whether g of x is an inverse involves applying the rule that the composition f of g of x must be equal to the composition g of f of x, which both must then ultimately equal x. We will begin by looking at the composition f of g of x. Recalling from our previous lesson, that means writing the function f of x with g of x substituted. Notice this substitution involves placing our g of x into the original f of x function where x was located. We need to continue by simplifying. Combining like terms, 5x plus 3 minus 3 divided by 5 results in a finding of x. We'll continue then looking at the next composition. Notice we have replaced the x in the g of x function with f of x in our original function. We continue by simplifying this, noticing that the 5 divides the 5, so we will have x minus 3 added to 3, and again our end result is x. We have therefore verified that both compositions, f of g of x and g of f of x, result in equivalent x's. We have verified that we found the inverse.